All right, so today we're diving deep into AI accelerators.
Oh, yeah.
Um, and you sent us a ton of articles and research on this,
Right.
which is great. Clearly, it's something that you're really interested in.
Mhm.
And to be honest, you're right on the money because this market is like exploding. I mean, we're talking a compound annual growth rate
Wow.
of anywhere from 22% to almost 40% in the next like few years.
Yeah.
But before we get lost in all the numbers,
Right.
let's start with like the basics.
Yeah, let's do it.
So, like, what exactly are AI accelerators?
Well, they're kind of like the secret sauce
Okay.
that makes all this AI magic happen.
Okay.
It's specialized hardware,
Okay.
kind of like supercharged computer chips,
Okay.
specifically designed to make those complex AI tasks
Uh-huh.
run super fast,
Gotcha. Okay.
like lightning speed.
So, like, I guess the difference between trying to run a complex simulation on my old laptop
Yeah,
versus using a supercomputer.
exactly. Yeah. AI just demands like a ton of processing power,
Right.
and these chips provide the muscle to handle it.
Okay.
Everything.
Yeah.
From recognizing faces in a photo
Yeah.
to helping self-driving cars navigate busy streets.
Yeah. So this isn't just like some abstract tech concept.
Right.
This is what's powering like this whole AI revolution
Well,
we keep hearing about.
Absolutely.
Okay.
They're the engine behind some of the most incredible advancements happening right now.
So from the stuff that you've sent me,
Right.
it looks like there are like different types,
Mm.
GPUs,
Yeah.
FPGAs,
Right.
ASICs, even CPUs are like getting in on the action.
Yeah. Yeah.
That seems like a lot of options.
It is.
How do they all like fit together?
Well, each type has its own strengths and weaknesses.
Okay.
And they're often suited to different tasks.
Okay.
You mentioned GPUs, which, a lot of people associate with gaming.
Right.
But these are like way more powerful versions designed for heavy-duty processing. And they excel at parallel processing, which is, handling tons of data at the same time, which is ideal for things like image recognition or training AI models.
So that's why you see them in data centers.
Yeah.
High performance computing.
Exactly.
Okay.
And then you've got FPGAs, which are kind of like the shapeshifters
Okay.
of the accelerator world.
All right.
They're incredibly flexible and can be reconfigured like on the fly,
Okay.
which makes them perfect for situations where you need to adapt to changing demands in real time, like video processing or robotics.
Okay. So for things where you need to like think on your feet, so to speak.
Exactly,
Yeah.
yeah.
Okay.
Then we have ASICs, which are more like custom-tailored suits
Okay.
designed for very specific AI tasks,
Okay.
which makes them super efficient but, less adaptable.
So if you have a very specific problem
Right.
that you need to solve,
Yeah.
an ASIC could be the way to go.
Yeah, they're optimized for peak performance in their like designated area,
Okay.
whether it's deep learning or natural language processing.
And then even CPUs are finding a place.
They are, yeah.
The brains of our everyday computers
That's right.
in the AI world.
CPUs are becoming increasingly capable of handling AI inference,
Okay.
which is essentially, using a trained AI model
Uh-huh.
to make predictions or decisions.
Okay.
While they may not be as powerful as GPUs for training,
Right.
they're proving very useful for less complex AI tasks.
Okay, so we've got this whole zoo of AI accelerators.
We do.
Each with its own strengths.
Yeah.
But why are they like experiencing such explosive growth?
It's actually the convergence of several powerful trends.
Okay.
First, AI is just becoming ubiquitous.
Right. It's everywhere.
It's not science fiction anymore.
Yeah.
It's being integrated into businesses and industries across the board.
Right.
Like everything,
Right.
from predicting customer behavior to diagnosing diseases.
It seems like AI is like the go-to solution for solving all sorts of complex problems.
It really is. And this leads to the second trend,
Okay.
edge computing.
Okay.
More and more, we need AI processing to happen right where the data is being generated.
Can you give me like an example? I'm trying to
Yeah.
like picture this in the real world.
So think about a self-driving car.
Okay.
It needs to make split-second decisions based on real-time data from its sensors.
Right.
There's simply no time to, send that data to the cloud for processing
Yeah.
and wait for a response.
Okay.
That means the AI processing needs to happen on board,
Okay.
which demands powerful and efficient AI chips right there in the vehicle.
Ah, that makes a lot of sense.
Yeah,
So it's about bringing that processing power closer to the action.
exactly.
Okay.
And finally, We have the growing emphasis on energy efficiency.
Mm-hmm.
As AI becomes more and more pervasive,
Right.
we can't ignore, the energy consumption.
Yeah, yeah, power all this stuff.
Right.
Right.
Just now. And we need to, power all these advancements sustainably.
So it's not just about making AI accelerators like more powerful,
Right.
but also greener.
Exactly. We need AI chips that are both smarter and more energy efficient,
Okay.
which is leading to some really incredible innovations in chip design and architecture.
So I'm seeing, from all this research,
Yeah.
you've got some big players
Mm-hmm.
in the AI accelerator game.
Yeah.
Companies we've all heard of,
Right.
like NVIDIA.
Yeah.
What's their role in all this?
Well, NVIDIA is definitely a dominant force in the market,
Okay.
particularly with their GPUs,
Uh-huh.
which are widely used in data centers and high-performance computing.
Okay.
However,
Oh.
they're facing increasing competition
Oh.
from other established players,
Okay.
like AMD
Mm-hmm.
and Intel.
I'm curious, what are AMD and Intel, bringing to the table? Are they taking a different approach?
So AMD has been making some serious inroads
Okay.
with their Instinct line of GPUs,
Okay.
which are designed specifically for AI workloads.
Right.
They're focusing on,
Yeah.
high performance and energy efficiency.
Okay.
And they've been gaining traction in the data center market.
Gotcha.
Intel, on the other hand, is taking a broader approach,
Okay.
leveraging their strengths
Yeah.
in both CPUs and GPUs.
Okay.
They're also developing these specialized chips called VPUs,
VPUs.
vision processing units,
Okay.
which are designed for AI inference tasks,
Okay.
especially in edge devices.
So it seems like the competition is really heating up.
It is.
It's not just a one-horse race.
It's not, no.
Yeah.
And it's not just the traditional chip makers that are getting involved either.
Okay.
Tech giants
Mm-hmm.
like Google,
Yeah.
Amazon,
Right.
Qualcomm,
Okay.
they're all entering the fray.
Wow.
With their own unique offerings.
Yeah.
Google, for example, has developed their own custom chips
Uh-huh.
called TPUs,
TPUs?
tensor processing units,
Okay.
which are specifically designed for their machine learning algorithms
Right.
and cloud computing platform.
Okay.
Amazon has
Yeah.
their Trainium and Inferentia chips,
Okay.
focusing on both training and running AI models in the cloud.
Okay.
And Qualcomm,
Yeah.
known for their Snapdragon chips
Right.
that power many of our smartphones,
Yeah.
is also leveraging their expertise
Okay.
to bring AI capabilities to edge devices.
So it's like everyone wants a piece of the
Bagel.
AI accelerator pie.
Yeah.
It's fascinating to see this convergence of
Yeah.
traditional chip makers and
It really is.
tech giants
Yeah.
shaping the landscape.
It certainly makes for
Yeah.
a very dynamic and rapidly evolving market.
But it's not just the big players
I don't
who
know.
are driving innovation
Okay.
in this space.
There's a whole wave of exciting startups emerging.
That's what I find so intriguing about this whole deep dive.
Mm-hmm.
You've got these established giants
Yeah.
with their vast resources and expertise.
Right.
But then you also have these
Yeah.
nimble startups
Yeah.
that are not afraid to push the boundaries,
Yeah.
challenge the status quo.
And some of these startups are doing some truly remarkable things.
Wow, okay.
One that really caught my eye
Yeah.
is Cerebra Systems.
Huh?
They've developed something called a wafer scale engine,
Okay.
which is basically a giant AI chip
Whoa.
the size of a dinner plate.
A dinner plate sized chip.
Yeah.
That's insane.
It's big.
What's the advantage of going so big?
Well, by building a single massive chip,
Okay.
they're able to eliminate
Okay,
a lot
yeah.
of the communication bottlenecks
Okay.
that plague traditional chip designs.
Oh, okay.
And this allows them to achieve significantly faster processing speeds
Right.
and handle much larger AI models
So it's like they're building a superhighway. Yeah.
for data to flow through the chip.
That's a great analogy.
Okay.
And then you have GraphCore,
Okay.
a UK-based company
Yeah.
that's developed a chip
Okay.
called the Intelligence Processing Unit, or IPU.
IPU.
It's designed specifically to handle
Yeah.
the massive, complex AI models of
Oh.
the future.
I remember reading about them
Yeah.
in one of the articles you sent.
Yeah.
They seem to be focusing on this concept
Mhm.
called sparsity.
Yeah.
Can you explain what that is
Sure.
and
Yeah.
why it matters?
So sparsity in this context
Okay.
refers to the fact that
Yeah.
many AI models have a lot of empty space in them.
Okay.
meaning that many of the connections between neurons
Yeah.
aren't actually used.
Okay.
GraphCore's ITU
Right.
is designed to efficiently process the
Right.
sparse data,
Okay.
which can significantly reduce the computational workload
Gotcha.
and improve performance.
So it's like they're finding ways to...
Streamline that AI processing by
Yeah.
focusing on the essential connections.
Exactly. And there are tons of other startups out there,
Oh, wow.
each with their own unique approach.
Okay.
Companies like
Yeah.
Tenstorrent,
Tenstorrent. Okay.
Grok,
Okay.
and Mythic
Okay.
are all making waves with their innovative chip designs.
From what I've gathered,
Yeah.
a lot of these startups are focusing on bringing AI power to edge devices.
Right.
Is that a trend you're seeing as well?
Absolutely. It's one of the most exciting areas of development
Okay.
in the AI accelerator space.
Okay.
These companies are creating smaller, more efficient chips
Right.
that can enable AI capabilities
Okay.
in everything from smartphones
Wow.
and smartwatches to industrial sensors
Okay.
and autonomous drones.
It's like the democratization of AI, putting the power of this incredible technology
Yeah.
into the hands of more people
Exactly.
and businesses.
And it's mind-boggling to think about
Yeah.
all the potential applications.
It certainly is.
And with this influx of new players
Yeah.
and new ideas,
Right.
the future of AI accelerators is looking incredibly bright
Okay.
and incredibly fast.
Okay.
Talking about advancements.
Yeah.
That could make today's technology look like something out of the Stone Age.
Okay, now you've got me really curious.
Right.
What kind of advancements are we talking about?
Okay.
Give me some examples.
Well, one of the most promising areas of research is silicon photonics.
Silicon photonics. Okay.
So instead of using electricity to transmit data on a chip,
Right.
they're using light.
Light.
Yeah,
Like lasers on a microchip.
that's right.
That sounds like something straight out of science fiction.
It does, doesn't it?
Yeah.
But it's becoming a reality,
Wow.
and the potential is immense.
Okay.
Using light instead of electricity could lead to speed boosts
Right.
thousands of times faster
Wow.
than what we have today.
So AI that can process information. Yeah.
At the speed of light?
Yeah.
That's just,
It's pretty fast.
I can't even wrap my head around that.
It's mind-blowing, isn't it?
Yeah.
And that's just one example.
Okay, so what else?
Another exciting development is
Okay.
DRAM on top of compute.
DRAM.
Yeah.
Isn't that
It is.
the computer's short-term memory?
That's right. It's where the data
Yep.
being actively processed
Yeah.
is stored.
Okay.
And by putting this memory
Mm-hmm.
directly on the processing unit,
Okay.
we can eliminate the time it takes
Yeah.
to move data back and forth
Right.
between the processor and the memory.
So it's like having all your tools and materials
Yes, sir.
right there on your workbench
Yeah,
instead of having to run back and forth to a
Yeah.
storage room every time you need something.
that's a perfect analogy.
Okay.
It streamlines the whole process.
Yeah.
Leads to lightning fast access.
So we're talking about faster processing speeds and what else is on the horizon? Flexibility and energy efficiency
Okay.
are also major areas of focus.
Yeah.
Researchers are developing chips
Yeah.
that can adapt to different tasks.
Okay.
So you don't need separate chips
Mm.
for each specific AI function.
So it's like a Swiss Army knife
In a way, yeah.
of AI chips.
Yeah.
One chip that can do it all.
And these chips are also being designed
Right.
to use less energy,
Okay.
which is crucial for both
Yeah.
cost and sustainability.
Yeah, just keep
For customers.
throwing more and more energy
We can.
at these problems.
We need to find smarter, more efficient ways to power AI.
Mhm.
That makes sense.
Yeah.
So all this is incredibly fascinating
Yeah.
from a technological perspective.
Right.
But I'm also curious
Mhm.
about the bigger picture.
Yeah.
What does all this mean
Right.
for the average person?
Yeah.
How will these advancements
Right.
in AI accelerators
Hmm.
actually impact our lives?
Well, imagine a world with AI-powered devices.
That are smaller,
Yeah.
faster,
Right.
and more energy efficient
Yeah.
than anything we have today.
Okay.
Think about smartphones
Mm-hmm.
that can instantly translate languages
Right.
in real time,
Wow.
or healthcare devices
Okay.
that can diagnose diseases
Yep.
with incredible accuracy,
Right.
all while running on a tiny amount of power.
Or self-driving cars
Yeah,
that can navigate complex environments with
exactly.
even greater safety and precision.
Right.
The possibilities seem
They do.
endless.
They really do.
It's both exciting and a little bit daunting
It is.
to think about the potential impact.
I understand
Mm.
it's important to approach these advancements
Right.
with a sense of both
Yeah.
optimism and caution.
Okay.
We need to be mindful
Yeah.
of the potential risks
Right.
as well as the
Yeah.
potential benefits.
You're right. It's
Yeah.
easy to get caught up in all the
Right.
amazing possibilities. Yeah.
But we also need to have
Mm.
a thoughtful discussion
Mm-hmm.
about the ethical considerations
Yeah.
and societal
And
implications
absolutely.
of these advancements.
As AI becomes more powerful
Right?
and more integrated into our lives,
Right.
we need to make sure
Yeah.
that it's used responsibly
Yeah.
and ethically.
Well, yeah.
We need to have
Yeah.
open and honest conversations
Right.
about the potential impact
Yeah.
on jobs,
Right.
privacy,
Privacy, yeah.
and even our understanding
Yeah.
of what it means to be human.
Those are all critical points.
Air.
It's a conversation we
Yeah.
need to have as a society.
We do.
And it's something that
Yeah.
we'll continue to explore in future deep dives.
Yeah.
But for now, let's shift gears and talk about some of the
Okay.
key takeaways
Yeah.
from all the information you've shared.
Sounds good. We've covered a lot of ground.
We have
From the technical details.
Yeah. of AI accelerators
Yeah.
to the potential impact on our
Yeah.
lives.
We've explored
Yeah.
the market forces driving innovation,
Mhm.
the key players, both big and small,
Right.
and the mind-blowing advancements
Yeah.
that are just around the corner.
Right.
But before we wrap things up,
Yeah.
I want to pose a final thought-provoking question to you,
right.
our listener. With all these advancements in AI accelerators, what will be the biggest impact on your life in the next 5 years? It's a question worth pondering. The future of AI is still being written, and it's a future we're all a part of. So what really struck you in all of this? What sparked your curiosity?
You know, for me, it's the sheer pace of innovation.
Yeah.
It's truly remarkable.
Yeah.
Just a few years ago, the idea of a dinner plate-sized AI ship or using light to transmit data
Right.
would have seemed like pure science fiction.
Right.
And now it's becoming a reality. It makes you wonder,
Yeah.
like, what will the next 5, 10 years hold?
Right. It's mind-blowing. It feels like we're on the cusp of something, like truly transformative.
Absolutely. And it's an exciting time to be following this field. It's clear that AI accelerators will play a pivotal role in shaping the future.
So to recap for you, our listener AI accelerators are the engines driving the AI revolution. And the market for this technology is absolutely booming. We've seen how these specialized chips are powering everything from facial recognition to self-driving cars and even more complex tasks we haven't even thought of yet.
And we've only glimpsed the future.
Mhm.
Advancements like silicon photonics and DRAM on top of compute promise to make AI even faster, more powerful, and more efficient.
We've talked about the major players, the giants like NVIDIA, Intel, and AMD, as well as those up-and-coming startups pushing the boundaries of what's possible. What stood out to you in all of this? What are you going to go research more on your own?
I think what's important to remember is that this is just the beginning. We're
Mhm.
still in the early stages of the AI revolution, and the potential is truly limitless.
Yeah, it's a journey we're all on together, and it's one that promises to be full of surprises and breakthroughs.
So keep exploring, keep learning, and keep asking questions. Who knows, maybe you'll be the one to make the next groundbreaking discovery.
Thanks for joining us on this deep dive into the world of AI accelerators. Until next time, keep diving deep.